Good day everyone, and welcome. Today, we delve into the fascinating world of generative models with our paper, VectorFusion, Text-to-SVG, by abstracting pixel-based diffusion models. We'll explore how VectorFusion, a novel model, generates intuitive SVG representations from text, pushing the boundaries of what's possible in design workflows. Stay tuned for an intriguing journey through this cutting-edge research. Our research introduces VectorFusion, a novel text-to-vector generative model. This model draws inspiration from previous works such as VectorAssent, CLipDraw, and StyleClipDraw. These models have been instrumental in guiding vector graphic generation, but they are not without their limitations. We identified two key problems that we aim to address with VectorFusion. Firstly, existing generative models are computationally expensive. This is due to the increased capacity required for forward passes through the generative model. Secondly, the quality and biases of the generated vector graphics are inherently limited by the stable diffusion model. Despite these challenges, we believe that VectorFusion represents a significant step forward in the field of text-to-vector generation. As text-to-image models continue to advance, we anticipate that VectorFusion will likewise continue to improve. VectorFusion is a significant advancement in the field of generative models. It builds upon the work of layer-wise image vectorization and Diffusion, optimizing closed Bezier paths with a differentiable rasterizer. This innovative approach allows us to generate abstract vector representations without the need for captioned SVG datasets, instead utilizing pre-trained diffusion models to guide the generation process. Moreover, VectorFusion showcases the potential of scalable generative models trained in pixel space. It offers interpretable, editable outputs, which can be seamlessly integrated into existing design workflows. This opens up new possibilities for the application of generative models, providing a reference point for future system designs. As we continue to refine and advance text-to-image models, we anticipate VectorFusion will continue to evolve and improve, offering even more capabilities and applications. Let's delve into VectorFusion, a groundbreaking text-to-vector generative model. This innovation was born out of a need for abstract vector representations, which are crucial in the realm of design. The beauty of VectorFusion lies in its intuitive application within existing design workflows. The image you see here provides an overview of VectorFusion's latent score distillation optimization procedure. It illustrates how the model employs score distillation sampling to bolster a vector graphics renderer and a latent space diffusion prior for raster images. This process is key to VectorFusion's ability to generate meaningful and usable vector representations. We're addressing a significant problem in the field of generative models. Existing models like VectorAssent and CLipDraw have made strides in guiding vector graphic generation, but they have their limitations. For instance, while text-to-image models such as DALL-E 2 and Stable Diffusion can produce high-fidelity images, they fall short when it comes to transforming these images into vector graphics. The importance of this problem cannot be overstated. The need for high-quality images that can be seamlessly transformed into vector graphics is paramount in advancing our field. However, the path to a solution is fraught with challenges. One of the major hurdles is the computational expense of forward passes through the generative model, which is significantly higher than contrastive approaches. Additionally, the Stable Diffusion model, which we use, has its own limitations in terms of dataset biases and quality. Despite these challenges, we believe that our work on VectorFusion is a step in the right direction. We'll delve into the details of our approach and its effectiveness in the following slides. Our proposed solution, VectorFusion, leverages pre-trained diffusion models to guide the generation of abstract vector representations. This approach extends the work of layer-wise image vectorization, or LIVE, and employs diffusion models as transferable priors for vector graphics. Now let's talk about the potential of vector fusion. It serves as a reference point for designing scalable generative models. These models are trained in pixel space, enabling them to be applied to new tasks. The outputs are interpretable and editable, making them suitable for a variety of applications. In essence, vector fusion is a novel text-to-vector generative model that can be intuitively used in existing design workflows. It showcases the effectiveness of distilling generative models and holds promise for future advancements in the field. Our research introduces vector fusion, a groundbreaking text-to-vector generative model. This model leverages pre-trained diffusion models to generate abstract SVG representations. These representations are intuitive and can be seamlessly integrated into existing design workflows. Now, let's delve into the approach of vector fusion. Unlike previous methods that utilize pre-trained vision language models, vector fusion employs a generative model known as stable diffusion. This unique approach sets vector fusion apart and contributes to its effectiveness in generating high-quality vector graphics. Our research builds upon and extends previous work, specifically the layer-wise image vectorization, or LIVE. We've optimized closed Bezier paths using a differentiable rasterizer known as Diffusion. Additionally, we've employed diffusion models as transferable priors for vector graphics, which is a novel approach in this field. In terms of methodology, we've managed to guide the generation process without the need for datasets of captioned SVGs. This is a significant achievement, as it reduces the dependency on large, specific datasets. Again, the use of diffusion models as transferable priors for vector graphics has been instrumental in this process. This approach has allowed us to create vector fusion, a generative model that can produce abstract SVG representations from text prompts. These representations can be easily integrated into existing design workflows, demonstrating the practical application of our research. Our research focuses on two main areas: problem formulation and experiment design. In terms of problem formulation, we acknowledge that our generative model, vector fusion, has its challenges. The forward passes through the model are computationally intensive, which can be a hurdle. Additionally, the quality and biases of the vector graphics we generate are inherently tied to the limitations of the stable diffusion model we use. Moving on to our experiment design, we've conducted comprehensive tests to demonstrate the effectiveness of vector fusion. Our results show that it performs competitively when compared to contrastive models like CLI-PIP. Importantly, our work with vector fusion provides a valuable reference point for future research. It showcases the potential of scalable generative models trained in pixel space, opening up new avenues for creating interpretable and editable outputs. Let's dive into the technical results of our novel model, vector fusion. This model showcases the power of generative models over contrastive ones like CLI-PIP. It's a testament to the potential of scalable generative models trained in pixel space, serving as a valuable reference point for future designs. However, it's important to note that vector fusion does face some limitations. The computational expense of forward passes through the generative model is higher than contrastive approaches. Additionally, the model's performance is inherently tied to the limitations of the stable diffusion model, including dataset biases and quality. But there's a silver lining. As text-to-image models continue to advance, we anticipate that vector fusion will also improve, evolving alongside these advancements. Now, if you look at the figure on the right, you can see vector fusion in action, demonstrating its capabilities in generating high-quality vector graphics. We've developed vector fusion, a groundbreaking model that transforms text into vector graphics. This model generates abstract vector representations by leveraging pre-trained text-to-image diffusion models. In terms of methodology, VectorFusion builds upon the layer-wise image vectorization and Diffusion, optimizing closed Bezier paths with a differentiable rasterizer. It also employs diffusion models as transferable priors for vector graphics. In essence, VectorFusion is a significant step forward in the field of generative models, offering a new way to create vector graphics from text and opening up exciting possibilities for future research and applications. VectorFusion has demonstrated its effectiveness by distilling generative models, showing a clear advantage over contrastive models such as Key 8-SIP. This approach serves as a valuable reference point for future designs of scalable generative models trained in pixel space, aimed at tackling new tasks. In terms of output and usability, VectorFusion produces outputs that are not only interpretable, but also editable. This makes it a versatile tool that can be intuitively incorporated into existing design workflows, enhancing the overall process. This combination of effectiveness and usability underscores the potential of VectorFusion in the field of generative models. While VectorFusion has shown promising results, it's important to acknowledge its limitations. It's more computationally demanding than contrastive approaches due to its increased capacity. Additionally, its quality and biases are inherently tied to the stable diffusion model. Looking ahead, we anticipate VectorFusion to improve in tandem with advancements in text-to-image models. This research indicates a promising future for this approach, opening up new possibilities for generative models in pixel space. We're excited to see how this technology evolves and contributes to the field.